So hello everyone, welcome to this Men&Mice webinar. My name is Peter Peterson and with me today is Karsten Strodman. Karsten, you are there?
Yes, still here. Hello.
Very good. So today's webinar is focused on the CAA record in DNS and explaining the record and why it is becoming a mainstream thing as of September. Now, please note that all attendees are on mute, but we encourage you to submit questions through the GoToMeeting control panel. We are also recording this session, and you will find this webinar and previous webinars along with the slides at our website. This webinar will be there within a few days if you need to drop off for any reason. And yeah. So having said that, Karsten, if you are ready, I think we should just let go.
Yeah, let's go. Thank you, Peter, for the introduction. Hello, my name is Karsten Strodman, and I'm in the Men&Mice services team. And today's webinar is about the CAA record. So we will first have a brief overview over the CAA record, and then we will look how the CAA record is being used. And then we look at what will change in September this year and why it become mainstream. And after that, now that we then know how or why the CAA record is important, we look in the nitty-gritty details of the CAA record, the different properties and the flags and what values can be in there. And at the end, we look at deploying the record. So we talk about what DNS servers today already support CAA records and how you can create CAA records maybe for older DNS servers that you still have running, and how you can test your CAA record. Now, the CAA record has been around for 4 years now. It is the Certification Authority Authorization record, and it whitelists one or more certification authorities that can issue X509 certificates. Now, X509 certificates are these certificates that you put in a web server or a mail server or a whatever server on the internet to secure and encrypt the traffic between a client and that server. Now, so far, the CAA record was nice, but not very helpful because there was no mandate to really use that record. And what's changing in September, and we will talk about that in more detail later, is that the certification authorities, at least the ones that are in the major browsers and that are the important certification authorities, they must check the record and must follow the content of the record if such a record exists for a domain. If you want all the details on the record, there's an RFC 6844, and we have the link here in the slides if you want to read the RFC and all the details. So first we have a look on how a certificate request works without a CAA record. Now here we have on the upper left corner a client, and on the upper right corner the certification server from a certification authority, and this is certification authority A. And this client, owning the domain name example.com, usually buys his certificates from this certification authority named A. Now, the usual way to request a certificate is to generate a key pair. A key pair that exists or that contains both the private key and a public key. And then the public key of that key pair is being sent over to the certification authority as part of a certificate signing request. Now, along with the public key, there's some metadata, like how long we would like to use this public key and for what domain names we would like to use this public key. And then the certification authority checks the request, and how it is checked is there's different policies depending on the certification authority. Usually it has something to do with email, that they make sure that whoever sends the email is the owner or can send email from the domain that is being requested in the certificate, in this case example.com. And if that check is successful, the certification authority sends back a signed public key. That is, the public key for example.com has been signed by the private key of the certification authority, thus creating a signature on the public key, and both the signature plus the public key form a certificate. And both then the public key with the signature from the certification authority and the private key are being stored on the web server or whatever server is being used. So there was nothing really DNS-y in this picture here, except maybe that the certification authority uses email and therefore the MX records for checking the legitimacy of the client to own the example.com domain name. Now, what can go wrong? There's a lot of stuff that can go wrong. Here's one example. Now, same picture, but we have the certification authority B on the upper right corner. So it's not the same certification authority that we had before, but it's a different one. It's B, it's a different company. And the malicious actor wants to buy a certificate for example.com. And for that, he has hijacked maybe a mailbox from a user inside the company owning example.com, and he sends a certification request with its own public key to this certification authority. And because he has broken in the mailbox of one of the employees of example.com, now that email comes from example.com and it seems to be legitimate. And the certification authority B will then just happily issue a certificate for example.com, and the malicious actor can do several things with that, maybe do a man-in-the-middle attack or other nasty stuff. Now, it doesn't need to be a malicious actor. It can also be, as an example, that if your company has a volume discount with a certification authority because you always buy with this one company and your purchase department has got a deal with that certification authority, but it's a big company and not everyone knows that. It might be that some other remote department of that company needs a certificate and then buys by a different different certification authority, and buying for a much higher price than needed, because they don't know about the default certification authority and they don't know about the volume discount. And that can also be prevented by the CAA record. So it's not always a malicious actor. It can also be just an actor that is not fully aware of how certification business works in that company. Now let's see in contrast how it works if the CAA record is in place. Here again we have certification authority A. So this is a legitimate request. A key pair is being created on the client for example.com. The certificate signing request is sent to the certification authority. The certification authority now, in addition to doing other checks, so they may still do and probably will do other checks like checking the email communication and maybe do other checks, they also fetch the CAA record from the example.com zone from one of the authoritative servers that for example.com. And they get the CAA record with all the values in there, and then they check the values, and especially they check whether their own name, certification authority A, is in the record. And only if their own name is in the record, they are allowed to issue a certificate for this domain. And in this case, everything is correct, so they issue the certificate. And then the certificate is being deployed on the web server. Now we look at on the case with the malicious actor. Again, we have certification authority B here on the upper right corner, and that is not a malicious certification authority, but it's one of the certification authorities that people trust because it's built in the browsers. So the malicious actor creates a key pair for example.com, issues the certification signing request to the certification authority, and the certification authority B now fetches the CAA record from DNS from the example.com zone, and that record only lists certification authority A as the company being allowed to issue certificates for the example.com. So there's a mismatch. They know that this certification authority is not allowed to issue certificates. So we get a big stop here, and there's no certificate being deployed and no certificate being issued to the malicious actor. And that increases the security of the whole public key infrastructure in the internet. So what exactly is now changing in September? So far, the checking of the CAA record was optional for the certification authority. And now the CAB forum, which is the certification authority / browser forum, which is a gathering of the CAs, the certification authorities that have their root certificates in the web browsers and the browser vendors, like Mozilla for Firefox, like Google for Chrome, and Apple for Safari, and Microsoft for Edge and Internet Explorer, and so on. They are all in this forum, and they specify the rules for the public key infrastructure in the internet. And now they have voted in March this year that beginning in September, especially 8th of September, that every certification authority that is in the browsers must check the CAA record before issuing new certificates. And we have the link here to the email from the CAB forum, where they explain the new rules brought forward. Now, this does not mean that every customer that wants to have an X509 certificate must have a CAA record. It's just mandatory for the certification authority to check whether there is a CAA record, and if there is a CAA record, they have to follow the rules and the information that is published in that record. If there's no record, it's just like before, there's no pinning of the certification authority. So if there's no CAA record, every certification authority can just do its own checks and then can issue certificates. So it's not required that you as a customer of a certification authority must have a CAA record, but not having one is less secure now. So having that out of the way, we have a detailed look on how the CAA record looks like. And here we have a CAA record for example.org at the bottom of this slide. It's in the beginning, we have the domain name, and that is the domain name that is the base domain name for the certificate. We come to that later, but let me also already tell you that the CAA record works in a hierarchical manner, meaning that if a certificate is being requested for some domain name down the tree from this base name, this CAA record will also apply unless there is another CAA record down the tree. So if there is a certificate being requested for, let's say, newyork.example.org, and newyork.example.org has no own CAA record, then the certification authority will go up the tree, that is, will go to the parents of the name being requested and looks for a CAA record there, and they go up until they find the top level domain, and they will not check for the top level domain because obviously that doesn't make sense. And if they find a CAA record there, that then will be used for that domain name. So this example.org is not only for the exact domain name example.org, but can also apply to all names below example.org. Then the record type is a CAA, Certification Authority Authorization Record. And then we have the flags. The flags can have two values today, either 0 or 128. It's a bit, it's the highest bit in a 60-bit number here. So we have a lot of flags available for later use, but currently only one flag, one bit is being used. And if there is a 0 in this field, that means that the property is not critical. If a certification authority doesn't understand the content of that CAA record, they are still allowed to process any other CAA records that can be there in the zone, because there can be multiple than one. And they can skip over this record with any data that they don't understand, because it is planned that there will be more properties and more different CAA records specifying different rules in the future. Currently, we have just 3 properties, but there will be more later on. If the property flag is 128, that means that this property is critical. And if a CAA doesn't understand to parse and use the data in the CAA record, they are not allowed to proceed with the issuing of the certification of the certificate. So they need to stop here and say, there's some CAA record in the DNS that we don't understand, but it's a critical one, and we don't understand it. It's maybe too new, or maybe it's a typo, and we don't process any further, and you have to first fix your DNS before we can issue a certificate. For today, there's only 3 properties being defined, and these properties are all being understood by the CAs. So today it's not really required to mark any CAA record as being critical or non-critical, but if you're in doubt, mark it as critical. And then we have the property, and we have currently 3 properties that are available. We have issue, which allows a certification authority to issue a certificate, and that is a normal certificate, a non-wildcard certificate for this domain. Then we have issue wild, which would allow a certification authority to issue a certificate as a wildcard. That is a certificate that works for this domain name, but all domain names down the road. And we can have iodef, which defines the address where reports of misuse of certification requests will be reported back to the customer. We will cover that in detail in a moment. And then for the issue property, we have the value, and the value usually is just the domain name of the certification authority that is allowed to issue a certificate for this name. So here, let'sencrypt.org, which is the free certification authority, is allowed to issue certificates for example.org and all names below. We can have multiple CAA records with different certification authorities in there. So you can have Let's Encrypt and Komodo and Torthy and Symantec and GeoTrust in there, if that is your choice, that you want to have certificates from these 5 players in the game. So you are not bound to have just one. You can pick all the certification authorities that you like. Still, if you just list 5, all the others cannot issue certificates, wrong certificates. So the issue wild property, that is for wildcard certificates, and that are certificates that have an asterisk in front of the domain name inside the certificate. And that means that the certificate is valid for this name, but also for all the names down the DNS tree that are delegated from this name. If you put just a single semicolon in the value field of either issue or issue wild, then you are declaring that you don't want any certificates for this domain, because it's an empty value there, meaning that no certification authority whatsoever are being allowed to issue any certificates. And that can be used for either issue or issue wild. And then we have the iodef property, and the iodef property defines a report channel that the CA can use to report malicious CA requests. Now, for example, CAB that we had in the example with the malicious actor, with the iodef property in the CAA record, the certification authority B could then report back to the owner of the example.org zone that there was a request for a certificate that was from a malicious actor or an unknown actor, and that information can be of use by the administrator of example.org. And we have two different values that can go into the iodef property. One is a mail address with the mail to URI, giving the mail address where the report should be sent, and the report is an XML document that is defined in RFC 6546, transport of real-time internetwork defense messages over HTTP TLS. So even though the RFC only defines that over HTTP TLS, it also works for mail. And the second one that we have here is a URL to a web server somewhere. It can be HTTP or it can be HTTPS, HTTPS being preferred. And that the issuing certification authority will send the XML document as a post command to that web server, and there needs to be some application in the background that then takes the XML document and works on that and maybe creates reports. And I guess there will be some vendors on the market that will offer ready-made applications for receiving these reports on the web server. So certification authorities can decide to have their own private property values in issue or issue wild, and they come after the semicolon. So here in this example, we have the standard value, which is the domain name of the certification authority that is allowed to issue certificates. And then we have an extra property value. Here it's called max validity equals 360. And that could be, and this is just an example, that could be the maximum validity of the certificate being issued in days. So if a certification authority issues a certificate and the request says, I want to have the certificate for 10 years, and this entry says, no, we only want certificates being valid for 1 year, 360 days, then it will do exactly that. These extra values are private, so meaning there are currently no defined ones, and it depends on each certification authority which one they use. If you work with the bind tools, for example, DNSX sign zone to sign your zone on the command line, you will see that the tools will escape the semicolons, even if they come into quotes, and that might trip you off and thinking that, oh, they changed the data and the certification authority will not be able to recognize this semicolon because it's escaped. So it's not there anymore. But that is not the truth. On May 10th this year, 10th of May this year, Mark Andrews, who is one of the developers of the bind name server, clarifies that backslash semicolon and semicolon are the same thing on the wire. And we have the link to the email here. You can read that afterwards. So don't worry if you see a backslash before semicolon somewhere automatically created by the bind tools. It's just okay. Nothing wrong going on here. So coming back to the hierarchical nature of CAA, there could be multiple CAA records in a domain or even in a subdomain of a domain for different branches of the tree. So here we have the example.org domain that has a CAA record for CAA domain TLD, And then there's us.example.org, which has a pinning to CAB domain TLD, and then is New York, ny.us.example.org has a pinning to CAX domain TLD. That means that the certification authority, if there is a certification request for New York, us.example.org, they need to first look at that level, and if they don't find a CAA record there, they need to go a level up, look for CAA there, go a level up, go a level up, go a level up until they reach the top level domain and they stop there. So that means that in this case, ny.us.example.org gets the certificates only from CAX, us.example.com gets a certificate from CAB, and asia.example.com, because they don't have an explicit CAA for their name, we go up one branch of the tree. Looking at example.com, we find that there is a CAA record for CA-A. So how do we deploy the CAA record? The CAA record is supported in all the newer versions of popular DNS servers. Newer versions means released in the last 4 years, roughly. So bind 9.10 and bind 9.11 have CAA record. Bind 10, or Bundy DNS, how it is named now, has support for the CAA record. The LDNS tools from NLNet Labs support CAA. The NSD server, not DNS, Power DNS, Google's Cloud DNS, and Unbound, they all support the CAA record. If you run older DNS servers like bind 9.8, bind 9.9, for example, you are on an enterprise Linux, Red Hat, SUSE Enterprise Linux, you might stuck with an old version of bind that doesn't support the CAA record directly. You can still use them because there is RC 3597, which allows to enter records that are not known to the DNS server in a common format, the so-called unknown resource record format. And that works with the older bind versions, even down to bind 9.4, but you shouldn't use that old ones anymore. But also works with Windows DNS, but only with the latest Windows DNS, 2016. So if you have Windows 2012 or even Windows 2008, you are out of luck. These don't support CAA. It works also with older NSDs and older Power DNS servers. To create a CAA record, there is the CAA record generator by SSL Mate. It's a website. You put in your domain name for which you want to have the CAA record, and then you tick mark all the certification authorities that are able to issue normal certificates or wildcard certificates for your domain, and the website will spit out the certification authority records that you can just copy and paste into your zone files. The website currently says that there's a lot of certification authorities that don't check for the CAA record, but that will change in September, because then in September every CA needs to check. With bind 9.11, there is a new tool called named-RR checker. And the purpose of that tool is usually to check resource records in a provisioning system. But as a side effect, this tool can also be used to convert DNS resource records with the data that are known to bind 9.11 into the generic format of RC 3597, which can then be used into an older DNS server. So what you can do is, if you have an older DNS server, you can install bind 9.11 on some machine in your network, maybe your workstation, create the records there, and then copy the result over to your DNS server and have it running there. And here's an example. The named-RR checker reads the data from standard input. So here I used echo to put that in and then pipe it to named-RR checker. And then the output can be copy and pasted over to a zone file. Without DNSSEC, a malicious actor can still spoof the CAA check done by the certification authority to steal a certificate. So while it is not mandated by the RFC nor by the CAB forum, it's still highly recommended that you secure your DNS zones with DNSSEC if you use CAA Record to be extra secure there. Because without DNSSEC, there's still the opportunity for a more skilled attacker to also spoof the DNS request and spoof a CAA record that isn't there and steal a certificate. Once you have your CAA record in place in your zone, you can then test the CAA record, whether it is working and is valid. And the popular SSL TLS test from sslabs.com also today tests the CAA record, whether that is present and whether it is correct formatted. So you do the test, and in addition to checking for the CAA record, you test all the other security properties of your website TLS deployment here. So that brings us to the end of this webinar. On this page, I have collected some additional information about the CAA record, and you can go there and read the additional information if you like to. Before we come to our question and answers part of the webinar, let me quickly tell you that we have more Men&Mice DNS training coming along. We have listed now a new training in Boston, Massachusetts, East Coast, US in August. There we have the DNS and bind hands-on class, and we have in Europe, in Zurich, Switzerland, and actually we are there at Switch, the Swiss top-level registry, having a DNS class there. And we have the advanced class, the 5-day class, also in August in Boston and also in September in Zurich. And I will be in either in Linux Hotel next week, DNS and bind in German language, or you can have me for the DNSSEC and Dane class in December. And it might be that we will list more classes in Germany after the summer. And the next webinar will be about the DNSSEC key signing key rollover. After 7 years after the root zone has been signed, that was in July 2010, this year, the key signing key of the root zone in the internet will be rolled. It will be changed. So a new key will come in existence and the old key will be phased out. And that will happen between July and October this year. And it's especially critical if you operate DNS resolvers. That means if you have a DNS server that resolves name for other people, even if you don't use DNSSEC for that resolver, it can still harm you, because all popular DNS resolvers nowadays will request DNSSEC information, even if they don't use it at the end. So what happens here is during the key signing key rollover, the result packages from the root zone will increase. They will increase especially in September, when both key signing key rollover and the zone signing key rollover will happen. In this webinar, we will explain how the key signing key rollover will work. If you do DNSSEC validation, how you make sure that you have the new key by October 11th, because October 11th, the old key will be gone. And if you don't have the new key by then, your DNS will stop working. So be alerted by that. And we also talk about the September event, the time when both the key signing key and the zone signing key will be rolled, and there will be new ones in the zone, and the answer packages will be bigger than normal. How to prepare for that and what can go wrong, and how you can protect yourself from your DNS being falling over. And that webinar will be on Thursday, June 1st 5 p.m. European summertime or 3 p.m. Greenwich Mean Time, 11 Eastern Daylight Time, and 8 o'clock Pacific Daylight Time. With that, I conclude this webinar and ask out to Peter, do we have any questions?
No questions yet, and everyone listening, you can submit your questions if you have one through the GoToMeeting control panel. But Karsten, while we are waiting to see if we have further questions, the CAA record and how that is kind of put mainstream by browser vendors there. Is this like a nice augmentation or a big step forward in keeping the North Koreans, you know, at bay?
So I wouldn't really say that the North Koreans can do anything there, even though a lot of stuff is attributed to them. It is a step forward. It's not a big leap. It's one puzzle piece that makes the internet public key infrastructure more resilient against attacks. For it alone, it helps a little bit, but it really helps together with other technologies like DANE, for example, that we have covered here in different webinars. And also Google, as one vendor in the CAB forum, they are pressing for other ways to make the public key infrastructure more resilient. For example, a certification transparency project, which requires that all certification authorities, if they issue a certificate, they have to publish that certification authority in kind of an audit log, a public log. And that public log is done cryptographically in a way that it's impossible to remove any data that is once being written in there. So it cannot be spoofed later on. It cannot be falsified later on. And all these are little puzzle pieces, and they work together to make the public key infrastructure more secure than we have that today. One thing that we have seen is that over the past years, it became apparent that Symantec, one certification authority, has misissued a lot of certificates. I think it was a number in the high thousands of wrongly issued certificates. The CAA record will hopefully prevent that, but also certification transparency will prevent that. The question is, what will happen when a certification authority is being caught to ignore the CAA record? Probably there will then be a voting in the CAB forum, and probably first time that happens, the certification authority gets a warning. But it might be that if it happens again, that a certification authority ignores the CAA record of a customer, that that certification authority is then being thrown out of the browser, and that basically kills the business for that certification authority. So that is something the certification authorities are afraid of. Hopefully.
Okay. Yeah. So some international policy there, it seems. That sounds nice, like a step forward. So the next question is if or when the CAA record will be supported by the Men&Mice DNS and IP address management solution, and I can actually answer that one. That will happen no later than September this year, that we will add support in our management platform. Now, next question from Jeffrey. Will browsers leverage a CAA record to check if a cert is issued by an allowed CA?
No, they won't, because also that's not really possible, because the CAA record is only valid to check at the time the certificate is being issued. So certificates have a lifetime of months or years, and a company or an organization can choose to go with a different certification authority, just changing the CAA record while still having certificates from a different certification authority. So like a company can decide to go with Let's Encrypt today and having CAA record today and getting a certificate that is valid for 90 days, and then tomorrow decide, oh, from tomorrow on we only buy from Komodo, and then they change their CAA record to Komodo. If a browser would check that, they would find a mismatch. But the CAA record is only giving the state and the intent and the policy of the owner of the domain at the time the certificate is being issued, not at the time the certificate is being in use. So because of that, browsers will not check the CAA record. That can pinning of then the certification authority to a domain that can be done with Dane. So that hopefully will be checked by browsers in the near future, because there is an RC how that should be done, being worked on in the IETF. It's still active, so people still work on that. Next IETF meeting is in Prague this summer, and maybe we will see it there, maybe we will see it a little bit later, because it's not so easy to get that done in the correct way, and they want to make it really, really correct, because browser users, what they don't like is if the browser just doesn't work because of some security foo. So they want to get it really, really right.
Thank you, Carsten. So, well, are there any further questions? I don't see. I don't see any further questions now. So, if these are not popping up the next few seconds, I think we will put this webinar to an end. Carsten, any further message from your side?
No, make your backups. Don't get ransomware.
That sounds like an excellent idea. Excellent advice. So, Carsten, thank you very much for this webinar. And for the people in the audience, we are looking forward to seeing you in the next webinar on June 1st or any future webinars. Until then, have a nice time. Thank you.
Have a nice time. Bye for now.